guys. So today is kind of a neat spatial thinking lesson. And the skill we're going to be focusing on is being able to draw tetrahedrals, which is kind of a really common geometry in organic chemistry. And we want to be able to represent those in 3D. And so our learning target says to represent a tetrahedral and its substituents. And those are just any groups that are attached using what's called wedge and dash notation. And so some of the illustrations and things I'll be using are from masterorganicchemistry.com. And so definitely check that out if you want to. Make sure to give credit where credit is due. All right, so let's get started. So first of all, why does this matter? So organic molecules contain carbon and hydrogen. When hydrogens are attached to carbons, a tetrahedral structure is typically formed. Even though we draw these structures in 2D on paper, it's important to be able to see, kind of with our mind's eye, or represent them in 3D, since their 3D structure relates to how they react or interact with other molecules. And it gives us an example of propane, kind of in three different forms there. The first is the skeleton notation. Then, kind of the second, we have the hydrogens and carbons kind of shown or expanded. And then finally, we have the 3D representation using ball and stick models. And so if we look, we kind of see that if we traced out kind of each of the bonds, they kind of form a fourfold tetrahedral shape. And so typically the best way to start thinking in 3D is to kind of build the molecules with a model kit. But of course, most of y'all probably don't have one at home. And so we're going to try to use a website called MoleView instead. But before we get to the site, let's go through just a couple of examples on how this wedge and dash notation works. So the way it works is wedges, they kind of look like a dark triangle. They are designed to represent when a bond within the molecule is kind of poking outward from the paper and it's coming toward you. The dashes, which are kind of alternating lines and spaces in a triangular shape, they are designed to represent when a bond is sticking through the paper and going backwards away from you. So it's like behind, the plane of the paper. If a line is just flat, kind of like a normal bond line, that represents a bond that's within the plane of the page. So wedges are punching out, the dashes are going behind, and then the plane lines are within the plane of the paper. Now, a little bit of kind of technicality when you're drawing these structures is, in reality, kind of all of the bond angles within a tetrahedral are about 109.5 degrees. However, when we're drawing the tetrahedrals on our paper, we typically make the angle between the two just normal kind of plain bond lines look to be a little more obtuse. And then the angle between kind of your wedge and your dash, which are kind of on either side of the plane, those are going to be drawn to look a little bit more acute. And so you can kind of see that throughout the examples, as the wedge and dash are acute to each other, and then the two other lines are typically drawn in an obtuse angle. And so I've got kind of a little tetrahedral built here that we're going to try to use to show you these three examples before we go to the site. So in this first example, let me rotate my little tetrahedral to match here. So we have the kind of green substituent leading at the front there. And then we have the red at the top, and then finally the yellow and blue kind of on the front and back. And so you'll note that the yellow is kind of sticking out towards us, the blue is going away from us, and then the green and red are kind of in the same plane here. So the green and red get the plain bond lines, the yellow gets the wedge, and the blue gets the dash because it's going behind while the yellow is coming to the front. Now let's suppose that we rotate the molecule kind of back just a little bit. And now what we see is kind of the green and red are still in the same plane. The blue is kind of still going backwards. The yellow is still coming forwards. So the yellow gets the dash, and the blue gets the wedge. And so it takes a very similar form to the first example. We just kind of rotated the base of the molecule around. All right, and done a little swap on the top as well. Then finally, kind of another way that we can look at the tetrahedral is if we kind of stand it up on two of the substituents and let the other two kind of stick in and out of the paper. So you can see the red and green are in the same plane of the paper. The yellow is kind of punching out toward us, and the blue is going back behind. So the yellow gets a dash kind of pointing up to the sky, and then the yellow gets a wedge pointing up to the kind of top of the paper. And then the blue gets a dash kind of also pointing in an upward direction. So now what we're going to do is we're going to transition over to MolView and actually do some practice by manipulating a little structure there. And so let me swap you over on my screen. All right, so here we are at molview.org. And so when you first pull it up, it should give you a screen like this. You can just go ahead and click close. And the way the program works is super neat. On the left, it gives you the option of kind of building molecules with a skeleton structure. And then on the right, it generates a 3D ball and stick model of the structure that you can then kind of like grab and twist around and look at from lots of different angles. And so we're going to practice with just a simple molecule, methane, which is one carbon with 4 hydrogens attached. And for more complicated molecules, you can search them using the search feature in this top left-hand corner, but for methane, we're just going to draw it ourselves. So we'll delete that current molecule, and then we'll start with a carbon, and we'll put 4 bonds off the carbon, and then at the end of each bond, we'll attach a hydrogen, and there we have methane. So then if you kind of scroll over, it should have a button that says 2D to 3D, and it will update the 3D view so that it matches what you've drawn in 2D. And so we're going to practice kind of turning the tetrahedral different ways and kind of drawing that using wedge and dash notation. So first of all, kind of in the ball and stick model, I'd like you to just kind of sketch, what we're seeing in the 3D structure right now. And for each of them, we're going to have that little carbon in the center. So I'm going to go ahead and make my little center dots while I'm at it. And then we'll kind of draw our hydrogens off to the side. So in this case, we have kind of a hydrogen coming to the front, a hydrogen to the back, and then one up and one down. And again, your ball and stick model is probably better than mine, but we'll just kind of work with that. There we go. It's probably a little more accurate. Okay, but now on to the wedge and dash. So we have our carbon in the middle, and the 2 atoms that are at the top of methane here, kind of in the V, those are going to be in the same plane. So we'll kind of draw them at an obtuse angle. Then we have 1 carbon kind of sticking out to the front, or 1 hydrogen rather. And then we also have 1 hydrogen kind of going back into the page at the back. And so we'll draw another hydrogen there as well. And I tell you what, just for clarity's sake, let me go ahead and put a carbon in the center. And that way it'll help us just a little bit. Okay, so again, we've got that bottom hydrogen sticking out of the page and that back hydrogen going back into the page. All right, so now what I'd like us to do is try rotating the molecule just a little bit and draw it from a different angle. So I'm going to take this front carbon and kind of pull it up. There we go. All right, so now my tetrahedral is kind of sitting like a triangle, if you will. All right, and now what's interesting is it looks like these back 2 carbons are kind of going, or back 2 hydrogens are pointing away from us. So here we're actually going to draw it with kind of 2 wedges. Those are going back away from us. Okay. That front carbon is coming towards us, so he'll get a dash. And then the top carbon is kind of in the plane, so he'll get just a normal, line there. All right. And so again, what we're just practicing is making our wedge and dash notation kind of match, how we're viewing the molecule. And when you don't have the molecule in front of you, but you still want to draw in 3D, you know, it becomes a little more standardized where you're following kind of the rules of, you know, a wedge and a dash and then 2 plane lines. But here we're just practicing kind of with our, you know, just our spatial thinking. And if I draw my ball and stick model, we've kind of got 3 as a little pyramid and then 1 on the top. Okay, so let's go ahead and rotate again and try another arrangement. So I'm going to pull up on this bottom carbon again. And now what I have is these top 2 carbons are going to be my wedges and my dashes. I have 1 hydrogen that's kind of sticking out of the page toward me. So we'll make that a wedge. And then the other hydrogen is going into the page away from me. And the other 2 hydrogens that are pointing downward will kind of be in the same plane. So get 1 there, 1 there, 1 there, 1 there. All right. And so let's try just 1 more kind of orientation just to get a little bit more practice. Let's try to turn it so that we are looking at kind of the underside of the carbon. And so what's happening here is we have all 3 of these carbons kind of pointing out toward us. So we'll draw those as wedges, kind of like a pyramid of wedges here. There we go, make this wedge a little bit better. And then we have that other carbon kind of sticking away from us in the back, and so it will get a dash. And so essentially we're just practicing getting used to wedges being drawn for atoms that are coming out of the page toward us, and dashes being drawn for atoms that are going into the page, you know, or away from us. And that one going out. There we go. All right. So now, kind of what you're going to be doing for the practice problems. Let me make that screen a little smaller right quick. And okay, well, I guess let me address these first. And so a few kind of common pitfalls to watch out for, you know, when you're drawing kind of the typical wedge, dash, and 2 plane lines, is make sure that you keep the angle between the wedge and the dash acute, smaller, kind of instead of obtuse. Because if you draw an obtuse angle between the wedge and the dash, this is what you're really conveying kind of as a side view, which is not a very accurate tetrahedral. And so again, make sure that when you have 2 bonds in the same plane that are those just normal straight lines, that those should be drawn a little bit more obtuse instead. Okay, so now what you're going to do for the practice is it's going to give you a molecule to look up on moleview.org. And so let's go back to that. And again, the lookup bar is kind of right here in the top. And you can type in just exactly the name as it says. So we're looking for methane, or sorry, ethane is what we're looking for. Ethane. All right, and we'll go ahead and click that and it will pull it up for us and kind of readjust everything. And so what you're going to do in the first column is draw the Kekulé structure that it gives you on the left. So for ethane, it's just a straight line. Then on the right, what we're going to do is go ahead and draw the 3D version using wedges and dashes. So here we have kind of a carbon here and a carbon here, have the bond between them. Then what we see is, if I can kind of use my cursor over here, this hydrogen kind of toward the bottom, if we trace all the way up through the carbons, it's going to be in the same plane as this hydrogen sticking out of the top of the second carbon. So we'll go ahead and kind of put those in. Those are just going to be normally kind of in the plane. Then what we have is kind of on the top of this first carbon, we have 1 hydrogen sticking out toward us. That will be a wedge. And then we have the other hydrogen going back away from us, which will be the dash. And again, we'll draw that angle to be acute. So this is an acute angle, and then the regular lines are an obtuse angle. Then we'll do it for the second carbon. That bottom one is kind of coming towards us, so we'll make it a wedge. And then the back one is going back away from us, so it becomes a dash. And so there we have kind of our 3D representation of this molecule. And I'll tell you what, let's just do one more while we're at it. Let's go ahead and do propane. So we'll search that up as well. Propane instead. There we go, propane. So there's lots of molecules. Also, if you get curious, you can look around. All right, and so they give us the calculate structure. And I'm actually going to flip my calculate structure around to kind of match the overall molecule just a little bit better. And so now, if we're drawing our wedges and dashes, we have our 3 carbons. Now for this top carbon, we have 1 hydrogen that's kind of sticking out toward us, and 1 hydrogen that's going back away from us, kind of in a V shape. So we'll use our wedges and dashes there. Then on this first carbon on the left, the bottom hydrogens, we have 1 sticking out, so that'll be a wedge. 1 sticking behind the paper, that'll be a dash. And then if we kind of trace the shape, move my cursor. So if we trace the shape, these 2 carbons on the hydrogen on the left and on the right, those will kind of all be in the same plane of the molecule. And if you kind of rotate it, you can kind of look along that middle line and see that those will fall in that same kind of plane. So we're going to make those kind of just a regular line there. And then we'll repeat the hydrogens, the wedge, and the dash on the other side. All right, so it just takes some practice, but go ahead and give those next few problems a try using MolView. And then make sure to check your answers with the key, and definitely let me know if I can be of help to you in any way, or come see me at office hours.